Okay, in this video we're going to look at properties of logarithms, how we can simplify logarithmic expressions and functions. So what I have written here is called the change of base formula. Basically, if you have a logarithm with any base, you can change it to a different base, a base that is more easily worked with or that you need for different reasons, different applications, using this. These other two are just specific bases that are seen the most often. So this is the general form, but you could take the same thing and change it to, this is, remember, log base 10. When there's no base written, that's base 10 because that is one of the more common logarithms that we work with. Or you could change it to the natural log using this formula. Both of these logarithms, the log base 10 and the natural log, are on almost all calculators because they are the most common. So if you have a graphing calculator or a graphing utility or online calculator, a lot of them will be able to calculate logarithms with any base. But if you have a simpler calculator with not as many functions, then you would have to convert it to base 10 or natural log in order to be able to evaluate it. So we are going to start with log base 4 of 25, and we're asked to calculate it using a calculator, right? So again, if you have certain calculators or certain programs, you could evaluate it on your calculator exactly as is. But if not, you would have to convert it to either base 10 or natural log. So we're going to do both. Using the formula, if we want to convert this to base 10, then both in the numerator and the denominator, we use log of base 10. The x, right, the number here, goes in the numerator. So in our case, that's 25. And whatever base we have goes in the denominator. So in this case, it's 4. Now, okay, now you should be able to use your calculator to evaluate this. If you take the log of 25, and that should be a button on your calculator, you should get something like 1.39794. And then if you take the log of 4, you'll get 0.60206. And then if you divide those, you get 2.3219. So I would encourage you that when you're doing your assignments, if it tells you to find your answer to 4 decimal places, as we've done here, then in each step before that, you need to keep at least 5 or 6, or you're going to have rounding error and you're not going to get the correct answer. So your final answer will be 4 decimal places, but every step prior to that, you'll need to keep track of at least one more place. Okay. Now let's try changing it to the natural log instead of base 10. We're going to use the same numbers, log base 4 of 25, but in this case, we're going to convert it to natural log of 25, natural log of 4. Remember, this is your numerator, this is your denominator. So if you take the natural log of 25 and you use your calculator for that, you'll get 3.21888. And if you take the natural log of 4, you should get 1.38629. And if you divide those, you get 2.3219. So you can see we get the exact same answer no matter which way we go, right? Now, we have some properties of logarithms that we can also use to simplify. We have the product property, which says that the log base a of uv is the same as the log base a of u plus the log base a of v. And this is the same for the natural log. You could replace log base a with natural log, and it's the same. This should make sense to you because when we do exponentials, right, if you have x squared times x cubed, when we simplify that, right, we actually add the exponents, 2 plus 3, to get x to the 5th. So this logarithm, which is the inverse of exponentials, is kind of doing the same thing, right? Multiplication really is just addition. The quotient property is similar. It says that when we divide u and v, that really is subtraction. We can rewrite it as log base a of u minus log base a of v. The power property says that when we have log base a of u to the n, that really is just multiplying, so the n can come out front and be multiplied times the log base a of u. Okay, so these power properties, quotient property and product property, will help us simplify logarithmic problems. So you will have some problems where you're asked to simplify log base 5 of the cubed root of 5 without using a calculator. So basically, use these three rules to simplify. So we need to rewrite this cubed root as an exponent. So remember that this root can be rewritten as an exponent, but it becomes the denominator of a fraction, right? So the cubed root is the same thing as the 1/3 power. The power rule here tells us that that exponent can come to the front. So this can become 1/3 times the log base 5 of 5. Then if we go back to the previous the previous video where we looked at the basic properties of logarithms, we know that when this and this is the same, that's always 1. So this is 1/3 times 1, or 1/3. Okay? Now the other type of problems that we will use, you may be asked to expand a logarithmic expression given a complex expression, break it down into simpler parts. That's what expand would mean. So let's take a look at that. So we could have something like log base 4 of 5x cubed y and be asked to expand it. That means use the three rules that we just looked at, the three properties, and write this out in a bigger expression. So first of all, we note that we have multiplication, right? We have three things. That's what's really happening here, multiplied. Those can all be rewritten as addition. So this becomes log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Now, this can further be simplified with the power rule here. So this would become log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And I'll do one more, a little more complicated. We'll use the natural log this time. The rules are the same, but we have this expression, okay? And we want to expand it. Well, first we will use our quotient rule here, right? Because we have division. So this can be rewritten as the natural log of this numerator, that whole thing, minus the natural log of 7. Now we have to remember that this square root can be rewritten as a fractional exponent. So this term is actually the square root of 3x minus 5, sorry, not squared, but to the 1/2, minus the natural log of 7. The power rule lets me bring the 1/2 to the front, minus the natural log of 7. And it actually stops here. Now, some students will get confused and want to take this minus and write it as a division, go backwards with the property rules, but they don't work that way, right? The minus, when it's in the natural log, we don't have a property that simplifies that. Division can go to two pieces that subtract, but when you have a subtraction inside the parentheses of the natural log, we can't simplify that any further. So this is where you stop. All right. Now, you can take an expression and expand it just like we did. You also can take an expression that has been expanded and condense it, put it all back together. So for example, if we have 1/2 times the natural log of x plus 3 times the natural log of x plus 1, we could condense this. So first we note that these things come here, right, as exponents. So this, sorry about that. Let me put that back up there. So we have 1/2 times the natural log of x plus 3 times the natural log of x plus 1. So as I was saying, the number out front, right, was an exponent. That's where it came from. So this becomes the log of x to the 1/2. Same here. This becomes the exponent. So the log of x plus 1 cubed. And then we remember what those fractional exponents mean, right? That really means square root. The bottom number on the denominator is the root. And now this plus, right, the product rule, that addition came from things that were multiplied together. So we can combine this into a single logarithm, remove the plus sign, and turn it into multiplication. And so that would be your condensed answer. Okay, so we'll look at one more, last problem. We have 1/3 times the log base 2 of x plus log base 2 of x plus 1. All right, so the order of operations still holds when you're doing with logarithms. You need to work inside the parentheses first. So we're just going to leave the 1/3 hanging out and simplify all that we can inside the brackets first. We have addition, so that came from multiplication. So that's the first thing we'll do. We'll rewrite this as log base 2 of x times x plus 1. Okay, and now we have this power rule, right? We can't simplify inside the parentheses anymore. So the power rule says that that was actually an exponent. So now this becomes log base 2 of x times x plus 1. And make sure you have these outer parentheses because that 1/3 has to go to the entire expression there. And then lastly, we remember that a fractional exponent is really a root, in this case a third root because a 3 is in the denominator. So we rewrite that as the cubed root of x times x plus 1.